नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE एंड नीट। आज हम आयनिक इक्विलिब्रियम में एसिड बेस थ्योरी के बारे में पढ़ने जा रहे हैं। देयर आर मेनी टाइप ऑफ एसिड बेस थ्योरी लाइक अर्हेनियस थ्योरी, ब्रॉन्स्टेड-लॉरी थ्योरी, लुईस एसिड बेस थ्योरी, बट टुडे वी फोकस ओनली on Bronsted-Lowry acid base concept. So according to Bronsted-Lowry acid base concept, acid is a substance which can donate proton and base is a substance which can accept proton. This theory is valid for water as well as other solvents, while Arrhenius theory is valid when solvent is water only. So this concept of Bronsted acid and base we are using in ionic equilibrium as well as organic chemistry, because in organic chemistry the solvent may be carbon tetrachloride, the solvent may be benzene. This theory is valid when the solvent is water or the solvent is other than water. So the concept of acid and its conjugate base is related to Bronsted-Lowry theory. Prove that in aqueous medium from Bronsted acid and its conjugate base and for Bronsted base and its conjugate acid, K into Kb is equal to Kw. The second point is, this is very common point we are using, if acid is strong then its conjugate base is weak. Like we are saying that HCl is a strong acid when it is added to water. Chloride ion in aqueous medium is a weak base. That is a true statement. Now the third statement is it correct to say that acetic acid is a weak acid, then its conjugate base is strong? We know that acetic acid is a weak acid, right? So is it correct to say that acetate ion is a strong base, or if it is a strong base then with respect to what it is a strong base? So we have to learn this third point. Let us start with an example, acetic acid in aqueous medium. So if we add acetic acid into aqueous medium, in short form I can write that acetic acid as HAC. It is dissolved in water, so it is present in aqueous medium. It will, on dissociation, it will form H plus ion which exists as H3O plus ion in aqueous medium and acetate ion in aqueous medium. Now the dissociation constant of this acid can be denoted by Ka, which is equal to K forward upon K backward. Equilibrium constant is K forward upon K backward. And it is given in the question that the K value of acetic acid is equal to 1.8 into 10 to the power minus 5. Means the reaction is moving more in backward direction with respect to forward direction. So here in this reaction there are two pairs of acid and base. So on the left hand side we are using 1 to represent the chemical species present on left hand side, and we are using 2 to present the chemical species on the right hand side. So I can say that this acetic acid as acid 1, water, since it is accepting H plus from acetic acid, so it is behaving like a Bronsted base, so water is base 1. H3O plus ion, we can write that this is acid 2 because it can provide H plus ion, and acetate ion is base 2 because it can accept H plus ion. So we are here dealing with two acids and two base. Now the equilibrium constant for this reaction I can write that Ka is equal to concentration of H3O plus ion into concentration of acetate ion upon concentration of acetic acid. So we can say that this is equation number 1. Since acetic acid is a Bronsted acid, its conjugate base will be acetate ion. In case of Bronsted acid and base, acid and its conjugate base is differ only by one proton. So acetic acid is a Bronsted acid, then its conjugate base acetate ion is less by a proton only, right? So why we are saying that acetate ion behaving like a base? So when acetate ion is present in water, it will accept H plus from water. So here water is acting like an acid for acetate ion. So it will form acetic acid on accepting H plus ion, and water is converted into OH minus ion. So for this reaction we are writing Kb for acetate ion. So Kb is equal to concentration of acetic acid into concentration of OH minus ion upon concentration of acetate ion. So we can say that this is equation number 2. If we multiply the left hand side of equation 1 and 2, we are going to get Ka into Kb. On the right hand side, since acetate ion is there in the numerator as well as denominator, it will cancel out. Same way, acetic acid is there in numerator and denominator, it will cancel out. So right hand side we can write H3O plus ion in aqueous state into concentration of OH minus, which is equal to ionic product of water, Kw. So we can say that K into Kb is equal to Kw if the medium is water. K of acid into Kb of its conjugate base is equal to Kw. So this is our first point. Our second point is, we want to understand that if acid is weak, then its conjugate base is strong. Is this statement correct or not? Because mathematically what we are getting here, that the value of Ka for acetic acid is 1.8 into 10 to the power minus 5, and the value of Kb for acetate ion is equal to Kw upon Kb. So Kw is 10 to the power minus 14 divided by Ka, which is equal to 1.8 into 10 to the power minus 5. So we are getting Kb is 10 to the power minus 9 divided by 1.8. So the value of Kb is also less than 1. It means that acetic acid is a weak acid and its conjugate base is also a weak base. So now we have to understand that if acetic acid is a weak acid, how its conjugate base is strong, and what is the meaning of this statement. So let us try to understand this statement. In this reversible reaction, we are talking about we are comparing two acids and two bases. And this reaction, we know that this reaction is moving in backward direction more than forward direction, because K backward is greater than K forward. So in kinetics we study rate of reaction is rate constant of reaction into concentration of reactant raised to the power their stoichiometric coefficient. Using that concept, if the value of Kb will be more, rate is directly proportional to rate constant. So if Kb will be more, the reaction will more move in backward direction. So here we are comparing two acid, one is acetic acid and the other is H3O plus, and the reaction is moving more in backward direction, means H3O plus can easily donate H plus with respect to acetic acid. So we can say here that H3O plus is a stronger acid with respect to acetic acid. Same way we can say there are two bases, water and acetate ion, and acetate ion can easily accept H plus ion to form acetic acid because the reaction is moving more in backward direction. So I can say that acetate ion is a stronger base with respect to, here this is a stronger acid, so this is a stronger base with respect to water. So now we can understand that when we are saying that acid is weak, its conjugate base is strong. When we are discussing these things, we are discussing in aqueous medium with respect to H3O plus ion and water. When we are saying that acetic acid is a weak acid, we are saying acetic acid is a weak acid with respect to H3O plus ion. And when we are saying that acetate ion is a stronger base, it is with respect to H2O. It is not a stronger base because the dissociation constant Kb is less than 1. So it is not a stronger base, but it is a stronger base with respect to water. So I think that I am able to convey the message that what is the meaning of if acid is weak, its conjugate base is strong. So this is our next example. Ammonia is in aqueous medium. So ammonia Kb they have given 1.8 into 10 to the power minus 5, and ammonium ion Ka is 10 to the power minus 9 divided by 1.8. So from the data we are getting that ammonia is a weak base and ammonium ion is also a weak acid. So the first thing is, whenever we are writing ammonia, most of the students when they are writing ammonia, they are writing NH4OH, that is ammonium hydroxide. When we are writing ammonia, ammonia is NH3, and ammonia is not an Arrhenius base because Arrhenius base can provide OH minus, NaOH is our Arrhenius base, KOH is our Arrhenius base, but ammonia is not our Arrhenius base. It cannot provide OH minus, it can accept H plus from water to increase the concentration of OH minus in the medium. So ammonia is not an Arrhenius base, it is a Bronsted base. And the second point, again we are going to revise that, is it correct to say that ammonia is a weak base, then its conjugate acid is strong? So now I think that we can find out the second statement is correct or not. So we are saying that ammonia is added to water, so NH3 in aqueous state, when added to water it will accept H plus from water to form ammonium ion, NH4 plus ion in aqueous state, and in the system OH minus ion concentration is increased because H2O is giving H plus, so it is converted into OH minus. So for this reaction, if I am writing that what is the dissociation constant Kb for this reaction, that is equal to equilibrium constant is K forward upon K backward. So again the value of equilibrium constant Kb is less than 1, it means that the reaction is moving more in backward direction and less in forward direction. Same way we can say here that this will be on the left hand side we are using 1, so ammonia is base 1. Water here is giving H plus to ammonia, so it is acting like acid, so this will be acid 1. Ammonium ion can give H plus to convert into ammonia, so we can say ammonium ion is behaving like acid 2, and OH minus can accept H plus to form water, so it is acting like base 2. So the equilibrium constant Kb for ammonia can be written as concentration of NH4 plus ion, concentration of OH minus ion upon concentration of ammonia. So this is equation number 1, and now we are saying that if ammonia is a Bronsted base, its conjugate acid is ammonium ion. So why ammonium ion is acting like an acid? Because NH4 plus ion in aqueous medium can provide H plus to water, so it itself converted into ammonia in aqueous state, and water is converted into H3O plus ion in aqueous state. So again, since ammonium ion is acting like an acid, we can write that dissociation constant of this acid is equal to concentration of ammonia into concentration of H3O plus ion divided by concentration of ammonium ion NH4 plus ion. If I multiply the left hand side of equation 1 and 2 on the left hand side, we can write that Kb into Ka. On the right hand side, ammonia is there in numerator and denominator, it will cancel out. Ammonium ion is there in numerator and denominator, it will cancel out. So on right hand side we are getting that it is equal to concentration of H3O plus ion into concentration of OH minus ion, which is equal to Kw. So again we have proved that base and its conjugate acid Kb into Ka is equal to Kw in aqueous medium. And now we want to understand the second point. We know that ammonia is a weak base, so I have to take this equation again. A reaction here we are discussing, in this reaction there are two bases, ammonia and OH minus, and there are two acids, water and NH4 plus. So now among these two, if we are saying that the reaction is moving more in backward direction, we are saying that ammonia and OH minus, since OH minus can accept H plus ion more easily, we will say that ammonia is a weaker base than OH minus ion in aqueous state. And since the reaction is moving more in backward direction, I can say that NH4 plus ion can easily provide H plus with respect to water. So I will say that NH4 plus is a stronger acid than water, right? So the meaning of acid and its conjugate base, we are saying ammonia is a weaker base with respect to OH minus, then NH4 plus its conjugate acid is stronger than water. So it is with respect to water and OH minus what we are saying, right? Here ammonia as well as NH4 plus both are weak bases and weak acid because their dissociation constants are less than 1, right? So now you can relate when we are saying that if acid is strong, when we are saying that HCl acid is added to water, so HCl in aqueous state, when added to water H2O in liquid state, it is converted into H3O plus ion in aqueous state and Cl minus ion in aqueous state. So we are saying here that this reaction is moving more in forward direction. The equilibrium constant of this reaction is very large than 1. So here this HCl is acid 1 and water is acting like base, so it will be base 1. On the right hand side we can say H3O plus ion is acid 2 and Cl minus is base 2. So if we compare here, we can say that since there are two acid, and if we compare these two acid, we can say that HCl is a stronger acid with respect to H3O plus ion, and hence when we are comparing water and Cl minus, since the reaction is moving more in forward direction, we are saying that Cl minus is a weaker base than water. Here also when we are saying with respect to water, right? Cl minus is a weaker base with respect to water and HCl is a stronger acid with respect to H3O plus ion. So hopefully you are able to understand what I want to give you, right? So if this information is useful to you, do not forget to like, subscribe our channel. Thank you.